Hey there, here's 815. So what we're going to do is compare and choose representations. So you'll be able to have a chance to kind of practice those representations that you've been working on. Box plots, stem and leaf plots, histograms. And then what we're going to do is we're going to be able to kind of hopefully make some decisions on what each one of these show as their benefit, okay? So just jumping ahead to 861, Mrs. Anderson's math class took a chapter test. She wants to find a way to display the data from those class test scores so that the students can easily understand it. Michaela thinks the best representation is stem and leaf because it organizes the information quickly. Gabe thinks that Mrs. Anderson should use a histogram because it gives a picture that's easier to look at. Jerry does not agree with either Michaela or Gabe. She thinks a box plot shows important information that the other two representations do not show. So you can kind of just think for yourself, discuss with your team, right, with which representations Miss Anderson should use to display the data on your paper, justify your choice. Go ahead and just make a choice. What do you think is best and why? No wrong answer there. So the test scores were listed here below. On the resource page, which I add on the second page, make a stem and leaf plot, a histogram, a box plot, and then use these bin widths of 10 for your histogram, and be sure to title and label all the representations. Make sure I do that last part. So what I did to save time is number one, I put them in order. I also listed that minimum, the maximum, and the median. The median falls between 76 and 78. So if we recall on how to find the median from there, we would find the number that's directly between 76 and 78, or you could add them both together, and then you could divide them by 2, and that will equal your 77. Okay, so first thing we're going to do is the stem and leaf plot. Okay, I already labeled my stem and leaf plot, the stem 5, 6, 7, 8, and 9, right? And so what I'm going to do is I'm going to highlight those in color. I'm going to highlight my 50s. I'll highlight my 60s. And the reason I'm doing this is just to help me understand, or help me to organize that data a little bit better, right? All right. So let's do that. We have 3. Oh, no, this is more for my histogram. That's okay. We'll just keep the colors here. 51, 55, 55, right? Let's put those in. A 1, whoops. That doesn't work very good, does it? There's my 51, here's my 55, and my other 55, right? 62 and 65. 72, 76, 78, and 79. So 2, 6, 8, 9. 2, 6, 8, 9. 82, 83, 85, so 2, 3, and 5. Whoops. And at 90, we have 91 and 93. Whoops, 90. There we go. Now let's build our histogram, which I kind of already started to do. What we'll do is go back up here. Let's just use those same exact colors. We had 3 in the 50s. So let's go to the 50s, and then let's bin widths of 10. So we just have to fill that whole bin width in there. And we had 3 of them in the 50s. So we're going to go 1, 2, 3. There we go. Okay. 2 in the 60s. What color did we use? We used green. Here's 2 in the 60s. And our 70s had 4 of them. I think we used yellow. And then we used red for our 80s, and we had 3 of those. And then last in the 90s, we had 2 of them, and we believe used purple. There we go. And there's our histogram. And last but not least, the box plot. I already labeled my minimum. Whoops, there I am again. 51. I think this was 77, and that was 90, I believe, 3. Yes, it was 93. Okay, let's go back up. Now we do need to find our first and third quartile. So I'm just going to kind of eliminate this stuff. Let's put our focus on finding the first quartile, which will be the median of all of that data. Okay, and you could cross it off. And we have 3 in each side. So our first quartile is 62. And if we recognize that same pattern from here, we can go 1, 2, 3. It's going to be our third quartile. 62 and 83. 62 and 83. And then, of course, we're going to, excuse me. Now we're just going to go ahead and fill in the rest to make the box. Horizontal line, and there we go. And there's our box plot. There's the stem and leaf plot. There's our histogram. And there's our box plot. Okay. Now we're going to answer the questions. The principal of Miss Anderson in her class school, Ms. Sievers, wants to get information about Miss Anderson's latest test scores that we had created in 861. He's interested in the class median, but also wants to know the percentage of students who scored lower than C+, less than 77 points in the test. What's the median of the class test scores? Which graph lets you see the median most quickly? Definitely we can see it in the box plot. Histogram's atrocious for that. You can find the median out of the stem and leaf, but it's way harder, right? So let's put our focus towards that at 77, and the best one that was the box plot. Okay. What percentage of students scored lower than a C plus or that 77? Excuse me. Well, we already know that if it's our median, that 50% or half the numbers will be less than that C plus. Which graph again helped us to make that decision? That would have been the box plot 2. That box plot shows us that 50% of those values have to be less than. So, Ms. Smith, another math teacher, also wants to look at Ms. Anderson's test scores. She wants to see information about how many students earn more than 60 points on the test. Which representation would show her this information? Justify your answer. Well, if we look at the 60 on the box plot, that would not work very well. We're not exactly sure where all those values are and how many. We could do this here in the histogram, couldn't we? Because we have 2, 4, 3, and 2, don't we? And then up here, more than 60, we could also do that here. Here's the 2, 4, 3, and 2 also. So you could make an argument that the stem and leaf or histogram is a good choice. I'd probably say the histogram, but your call. 6, 7, 8, 9, 10, and 11, right? So which would be easiest? I felt the histogram, right? And just for those reasons that I was talking about, again, make sure you justify your answer. Is your answer to this problem the same or is different from your answer part A of problem 262? What is the median? Which graph? Oh, meaning which was it the same one, box plot, histogram? It wasn't, right? And no, because certain graphs help us to see things a little bit differently, don't they? Just like we had talked about. Make sure you justify with your why or why not. Miss Anderson still does not know what kind of representation she should use. She knows that the representation shows different kinds of information using that representation that you made in problem 6 or 861. List and explain the measure of central tendency or others. It'll be easily read from each kind of graph listed below. List the information that will not be easy to obtain. Justify your answers. I'm not even going to list them down here. I want you to just follow along as we talk about them up here, okay? Let's start with the top. What's good about stem and leaf plots? Well, number one, you can see each number, can't you? Each number is very easy to do, easy to see in there. You can find the median. It's not the easiest, but you can do that. Min and max are super easy to find. Everybody's individual scores are easy to find. Scores above a specific number. On the histogram, I couldn't do something like 63. That wouldn't work very well, would it? But I could easily do that here. What's greater than 63 or less than 63? Do I have any numbers that are 83? I can't do that with the histogram or with the stem and leaf plot. So that stem and leaf plot does a really good job of organizing the data, and also allows us to see some of those things, right? We can easily find the range too. The mean is also accessible. This is the only one that will allow us to see the mean, because we can add up the individual numbers and divide by the amount of them. What's the histogram good for? Well, we can't really tell the range, we can't tell the median, and we can't tell the mean. So is this really that effective? Yeah, it does. It really helps us to kind of see the shape, though, doesn't it? Is it single peak, double peak? And some of that helps to kind of tell you where that data is sitting in here. Such a useful tool, too. Very easy visually to pick up with. The box plot. Box plot, easily to find the range, median, first quartile, third quartile. You can see the interquartile range, which allows you to see, remember that's inside the box, right? That's this area. And that easily helps us to find where 50% of that data is. It can see where the spread is, right? Is stuff really spread out? If you recall from the previous lesson, we had some outliers, and that really can show up in a box plot very easily, right? All right. Now, under the learning log, why don't you just take a second to write a little something about what kind of data displays can you use for these statistics? What numerical information can you give to describe center and spread? How can you describe the shape of the data? I just talked about all of these, and just to help, it's what a fantastic review. The box plot sometimes is also known as box and whisker plot, because it has a box with whiskers on it. So for all you cat lovers out there, maybe you find that really entertaining. So I'll let you just read the rest of that. Here are core answers here, right? And then down here, I'm going to encourage you to make sure that you're doing that, getting that proficient and robust. Show me those previous attempts, right, and what it took to get to them. All right, good luck, and let me know if you have any questions.